So next topic is in unit 2. Next topic is AC current waveforms. This analysis from with overlap. So in with overlap conditions, we analyze the waveforms whenever the alpha varies, how the output value is varies. So in AC current waveform, it is assumed that the direct current has no ripple. The DC has no ripple. Already we taken that assumption or harmonics because of the smoothing reactor provided in series with the bridge circuit. Normally smoothing reactor serves two purposes. First one is it eliminates harmonics, it eliminates ripples. Second one, it provides protection for the circuit. Whenever the over current flows in the circuit, the smoothing reactor cannot allow that overcurrents. The AC currents flowing through the valve secondary and primary winding of the converter. Transformer contains harmonics. So already in transformer does not provide exact sinusoidal waveform, so that will contains harmonics in transformers. The waveform of the current in wall winding is shown in figure. So AC current waveforms, please see the by using a pulse number. Pi is the pulse number. So this is a current, DC current. So whenever the number of pulses increases, how the waveform is changes. Please observe the AC current waveforms with overlap condition. So by Fourier analysis, the peak value of line current of fundamental frequency component is given by Ip is equal to 2 pi by integral minus pi by 3 to pi by 3 id cos theta d theta. Solve this equation. Ip is equal to 2 pi by pi id integral minus pi by 3 to pi by 3 cos theta d theta. Ip is equal to 2 id by pi sin theta. Limits varies from minus pi by 3 to pi by 3. By solving this equation neatly, we solve the equation neatly, we get Ip is equal to 2 root 3 by pi id. Ip is equal to 2 root 3 by pi id. So now the RMS value of line current of fundamental frequency component is given by IRMS is equal to Ip by root 2. IRMS is equal to 2 root 3 by pi into ID by root 2. We get IRMS is equal to root 6 ID by pi. In is equal to I by n. There is a n is a harmonic content. Generally, the RMS value of nth harmonic is given by fundamental current. I is a n is the nth harmonic, nth order harmonic. The harmonic contained in the current waveform or the order is given by h is equal to np plus or minus 1, plus or minus harmonic content, where n is an integer, p is the pulse number. Already we know. For a 6 pulse bridge converter, the order of AC harmonics are 5, 7, 11, 13 and higher order. So normally the dominant orders are 5, 7 and 11. So above 15, 17, 19 harmonics are the undominated harmonics. Because of that harmonics, the shape of wave not changes. The order of harmonic 5, 7, 11 will change the wave shape of AC quantities. They are filtered out by using tuned filters for each one of the first four harmonics and high pass filter for the rest. Please observe the waveform. So this is a three-phase waveform, positive group and the negative group. This is the waveform for firing angle. Alpha is equal to 0 degrees only. Alpha is equal to 0 degrees. Now the alpha is if the firing angle is 0 degrees. Here the fires. The 6 pulse means 1, 2, 3, 4, 5, 6. 6 pulse is generated by using this sinusoidal cone. Please observe the fundamental current. This is a DC current. This is a source voltage. Please observe the waveform clearly in 6 pulse converter. we take in the firing angle alpha is equal 0 degrees only. We not given any firing angle, so the converter act as a rectifier here because we using the alpha is equal to 0 degrees only. So in positive group means thyristor 1, 3, 5 will be activate. In the negative group means 2, 4 and 6 thyristors will be activate. Normally, valves are GTOs or IGBTs. Here we take as firing angle alpha is equal to 30 degrees. Whenever the alpha is equal to 30 degrees, how the same wave will be changes. Please see, please observe the waveform before and after. In 6 pulses, please observe the output here. But in alpha is equal to 30 degrees, the wave will be generated will be just like a sawtooth. Now the alpha angle increases, the wave will be changes just like S. So this is a line current, this is a fundamental current. The voltage and current waveform alpha is equal to 30 degrees. We can change the alpha value up to 90 degrees. Up to 90, that is not invalid. Up to below 90 is a valid. Please observe this waveform. Please compare both alpha is equal to 0, alpha is equal to 30 degrees waveforms. Thank you.